Asteroids and near-Earth objects, NEOs, play a significant role in our solar system. Science fiction writers and filmmakers often craft stories involving asteroids, whether it's a catastrophic collision with Earth or futuristic asteroid mining colonies. However, the problem with most asteroid-themed movies is that they assume a large object is hurtling toward us, and we can simply blow it up. In reality, planetary defense against asteroids is far more complex. The reality of asteroid threats. What if an asteroid were on a collision course with Earth? Although this scenario seems unlikely, it is not impossible. Asteroids are rocky remnants from the formation of our solar system approximately 4.6 billion years ago. Most of them orbit between Mars and Jupiter, where Jupiter's gravitational pull prevents them from merging into a larger planetary body. However, there are asteroids and comets that have been nudged by the gravitational influence of nearby planets into orbits that intersect with Earth's. These are classified as near-Earth objects, NEOs. Though they have only been actively monitored for a few decades, predicting their trajectories remains challenging due to various uncertainties, such as their shapes, distances, and surface features. A close encounter, Apophis. One notable example is the asteroid Apophis, named after the ancient Egyptian deity of chaos. Discovered in December 2004, Apophis initially appeared to have a small chance of colliding with Earth on April 13, 2029. With an estimated diameter between 1,115 and 1,214 feet, roughly the size of the Rose Bowl, such a collision would be unprecedented in recorded human history. Fortunately, better data revealed that Apophis will safely pass Earth in 2029, although future encounters in 2036 and 2068 will be closely monitored. Scientists have identified a phenomenon called the keyhole effect. If an asteroid passes through a very narrow gravitational zone, Earth's gravity could alter its trajectory, increasing the likelihood of a future impact. If Apophis were to thread this keyhole, it could strike the Earth's surface, potentially plunging into the Pacific Ocean, generating a 3-mile-wide cavity, and triggering a tsunami 5 stories high that could devastate the western coast of North America. Mitigation strategies. Avoiding such catastrophic events requires innovation and preparation. Scientists have proposed solutions like the gravitational tractor beam. In this method, a spacecraft would hover near the asteroid, using mutual gravitational attraction to pull the asteroid slightly off course. By firing small retro rockets, the spacecraft could gradually nudge the asteroid out of its collision path, preventing disaster. Another option involves changing an asteroid's speed or direction through controlled acceleration, a process that can sometimes happen naturally. In Apophis's case, measurements show it is drifting about 500 feet per year from its predicted position. As of February 2021, the likelihood of a collision during the 2068 flyby has been reduced to less than 0.0067%, thanks to refined observations by experts like David Tholen at the University of Hawaii. Learning from history. The danger of asteroid impacts is not new. Approximately 65 million years ago, an asteroid the size of Mount Everest struck the Yucatan Peninsula in Mexico, leading to the mass extinction of 75% of Earth's species, including the non-avian dinosaurs. This event highlights how localized impacts can trigger global climatic consequences. More recently, in 1908, a small asteroid exploded over Tunguska, Siberia, flattening 830 square miles of forest. Scientists believe the explosion resulted from an iron meteorite rapidly heating as it passed through the atmosphere, causing a shockwave that obliterated the area. Had it been a direct impact, it could have caused a 2-mile-wide crater and catastrophic damage to the biosphere. Preparing for the future. NASA and international organizations are working to reduce the threat from NEOs. There are now telescopes and observatories dedicated to identifying and tracking asteroids that could intersect Earth's orbit. To date, over 10,000 NEOs have been discovered, though countless others remain undetected. While no known asteroid currently poses a threat to humanity, the need for vigilance is clear. Scientists emphasize that prevention, whether through gravitational deflection or controlled interventions, is far more effective than attempting to destroy an asteroid at the last moment. Unlike the dinosaurs, we have the technology to prepare and act. Conclusion: an asteroid impact would have catastrophic consequences, from creating massive craters and tsunamis to altering Earth's climate. However, with continued advancements in planetary defense and international cooperation, we have the tools to prevent such a catastrophe. By tracking NEOs, refining impact predictions, and developing mitigation strategies, we can safeguard Earth from future asteroid threats